computer. Okay.
Great, thanks, Irene. So yes, it's my pleasure to introduce Declan Phillips, who's a colleague from UL. Declan is a senior lecturer in civil engineering at UL, and came to UL originally to set up the civil engineering program. And one of the interesting things about that program, thanks to Declan's work, is that it has a commitment to a PBL approach throughout it. So Declan has his undergraduate degree in structural engineering and a postgrad in geotechnical engineering. And the other thing about Declan is he has a great interest in education, and has actually just submitted his MA in teaching and learning and scholarship dissertation. So, and I know that at least some of that work Declan will talk about today, but he's more specifically focused on a specific case study around the transition of his particular module to a blended delivery mode. So thanks for joining us, Declan, greatly appreciated.
Thanks very much, Mike, and everyone is very welcome. In today's presentation, I'm really just going to tell a story. I'm hoping that it will provoke some good discussion at the end. I think my experience generally in attending these things is that the most fruit is available at the end of the presentation. The presentation just serves to light the fire. So I'm hoping that's what will happen here. I suppose I want to start by perhaps acknowledging why we are here. There's been a lot of, very sad stories associated with COVID, but one of the things that it has done, it has forced the academics to think about how they'll engage students in a totally unfamiliar environment. We started a standing start overnight. We had to decide how we would organize our material. We had to decide how we would assess it, how we would protect the integrity of the system, and do all of this pretty much on our own. If you look at institutions like Open University, for example, who have been doing online teaching for many, many years, they've got a whole array of support backing them up, from pedagogical experts to graphic designers to people that monitor their virtual learning environment and so on and so forth. So we really have undergone a dramatic change, and I would think, I don't know if other people agree, but the amount of change that has taken place wouldn't have taken place in my lifetime without COVID. That would certainly be my view. The second thing I want to say about the situation we found ourselves in is that for many years I had been planning to engage more with the online side of things, and in a sense COVID provided an opportunity to do that. So that's just the background, I guess, and to set the scene with respect to what I want to do today. I know there are people from many different disciplines attending, so I just want to very, very briefly talk about civil engineering, just so that everyone is clear what they do. I then will move on and talk about our program in civil engineering at UL. I think it's novel in many respects, and I'll try and highlight some of those novelties throughout the presentation. I'll then talk very briefly about the way we were and the way we used to do things and how this has changed. And out of that, and out of the experience of the past 2 years, I'll highlight what I think is going to remain. And I'll qualify some of those things with some student reflections, and I'll leave you with some questions to ponder. I have views on these questions I'm happy to share with you, and I think you probably have your own views. And more than likely, and this is the great thing about education, we're probably not going to agree on them all, but I always find when you hear other people's points of view, your own view is enriched from that. So civil engineering is one of the oldest branches of engineering. It's second only to military engineering, and as the name implies, it is engineering for civilians. So every single thing that we encounter in our day-to-day lives, whether it's the roads we drive on, the trains we take, the tunnels now that are becoming more popular throughout the country, bridges, orchestras, you name it, water supply, all of these are within the remit of the civil engineer. So I guess one little anecdote that I like to tell starts with a question, and it asks people, what profession do you think has contributed the most to our longevity? In other words, why are we living so long? And many people will say because of medicine, but the reality is because of civil engineering. Prior to our ability to provide clean drinking water and take foul water away, people were dying in their 20s and 30s from very, very curable diseases. And you can see that today in third world countries. So I'm obviously very proud to be a civil engineer, and I think it's a wonderful profession. So I'm in the business of educating the future generation of engineers, and this is how we do it in UL. So you can see a matrix there of what in most cases would be viewed as a series of boxes, but within those boxes there is a lot of life and a lot of energy and a lot of excitement. So PBL activities are numbered there 1 through 13. So over 50% of the civil engineering program at UL is driven by problem-based learning. The grayed out boxes are modules that would be delivered in a more traditional way. Many of them are service modules from other departments, but the core civil engineering discipline is predominantly driven by a problem-based scenario. And just for the record, I'm not precious about the term problem-based. There's many approaches that derive from the constructivist model, and I pretty much favor a blend of whatever works. The mission that we share in the civil engineering team is that we are about helping students to become independent learners. We want them to be able to approach a complex problem that has many different solutions that are viable and economic, and give them the skill set to be able to solve these problems. And in doing it, they can do it in a creative way, because creativity enhances education. Simultaneously, because of the pedagogy that's chosen, we develop other skills that are much sought after by industry. So collaborative skills, the ability to work in team, the absence of fear, perhaps, in standing up before your peers, or in a construction meeting or whatever, and communicating effectively to your audience. They are core values throughout the program, and I think you'll see those emerging from what I share with you as we go through today's talk. I firmly believe that learning, deep and meaningful learning, takes place through human encounters, and also something that I know some people would not like to broadcast, but I think we learn most of our knowledge through making mistakes, and I think that's to be encouraged in undergraduate education, so that your understanding can be broadened and deepened. And indeed, one of the modules that I teach looks very much at mistakes that were made in the past in forensic engineering. We favor this type of approach over this. We often feel in these scenarios that our students are just not engaged, and you'd like to light a fire underneath them. But we must remember that the educational system that we're operating in today has been in existence for over 200 years, and very little has changed, whereas in our students' lives, everything has changed. They are connected 24/7. The phone is practically part of their body at this stage, and they're getting multiple messages every 5-6 seconds. So to try and engage them by having them sit still for a period of 50 minutes, it just doesn't work in my view. There is a place for it, but it has to be done with a holistic view, and preferably in a scenario where the students' appetite for the knowledge you're going to impart in a lecture is there. So they're like sponges. I'm going to talk about one of the PBL activities here that occurs in second year, just to kind of show you the active nature of the way things were prior to COVID. So I start at the top of the left. We've got a number of buildings on campus that are on the banks of the River Shannon, and the image in the top left shows the aftermath of a flood back in 2015. Now, the engineers at the time were well aware of this scenario and have located the buildings at an appropriate height, but the students don't necessarily need to know that. And furthermore, with global warming, there are predicted sea level rises. So in time, these buildings could indeed become vulnerable. So the challenge for the students in this case, the trigger we use, is to design a series of flood embankments around the building that will protect them from future flooding. So this falls within a subject called soil mechanics, and we use that trigger to uncover the syllabus. And I'm going to say you'd be surprised, but maybe you wouldn't. On day one, without any soil mechanics knowledge, through dialogue, students are able to identify what the key challenges are. So they can discover the syllabus for themselves. That means they have a reason to learn. They can see the benefits of engaging. So we start with that project by getting a JCB, or excavating equipment, bring the students on site to look at the soils that are in the vicinity of those buildings. We do that for two reasons. We want to see what strength the soil has, and we're also seeking a location where we can get appropriate soil to construct the dam from. The next image shows some of the students testing the strength of the soil on site. And then photograph D shows the students in the lab, what I would call playing with sand, but there's a lot of meaningful learning that takes place in this process. They're learning how dams can fail. So they're building small dams out of sand, putting water behind them, and watching the various ways that problems can occur. They then go about selecting the most appropriate material based on what they brought back from site. And image F then shows the students working in teams, discussing the problems and how to structure their learning. Image G shows the students undertaking a graphical approach to determine how much water will flow through their dams. Image H shows them on site building a trial embankment to test whether their design works. And then the last image on the bottom right shows the students presenting their findings. So back to our program then, we looked there at, for example, PBL 6. It's in the second year of the program. So this is PBL 6, and later on in this series of lectures, my colleague Ross Higgins will be talking about another trigger which combines two modules. So I'll leave that with Ross. What I'm going to talk about today is this PBL 9. This is quite an interesting and challenging problem. It involves, as you can see, the entire suite of modules over the semester. So 5 modules are involved, and this PBL exercise comes right before the students go on an 8-month mentored work experience. So it's wonderful preparation for them going into a work environment. So talking about PBL 9, so this project is a different project every year. It's a real project. We usually take building structures that have just received planning permission, and we then obtain the appropriate data. So for example, every building design starts with an architect's input. The architect is involved with determining the aesthetics of the building, its form, and its dimensions. And at that point, the project is handed over to the engineers. Obviously, it's a team effort, so it's not like they don't interact at any point, but for the purpose of this discussion, I'm going to focus on the engineering side of this project. So this year, we worked on a very exciting project that's taking place in Limerick. It's part of Limerick 2030, and it's the new opera site. And the image you see here is one of the proposed buildings on this project. The students are required to analyze the structure for whatever impacts it might take. So that might be from wind loading, and obviously people occupying the building will put weight on the floors and so on. So the students have to be able to undertake structural analysis to determine the impacts of those weights on the structure. The structure is, at least in our context, is going to be constructed out of reinforced concrete. That's what RC stands for in the little box. And my own particular area is in soil mechanics, so I'll be biasing the input from soil mechanics in my discussion on this project. From the soil mechanics standpoint, there are 2 requirements for this structure. Number 1, that the ground has to be strong enough to support the building, and number 2, that it won't undergo significant settlements, so the building becomes cracked and damaged. Part and parcel with these activities is issues such as are associated with professional practice, that is taking risk assessments, surveying the site, number 1, to make sure the site is big enough to accommodate the building, and following construction it would involve positioning the columns and foundations at the correct locations. Also being located in a center city location, there are issues associated with access to the site, particularly for supplies, so concrete, trucks, and so on. And in the long term, how can a transportation plan be derived to make transportation more sustainable? So all of these individual modules are interlinked. In a traditional program, that is a program driven by lectures, these tend to be more siloed, that each stands alone and they're not necessarily interlinked. I think there's a number of, I suppose, highlight points that I've come across in my reading, and I've generally highlighted these in little yellow boxes. The first of them has appeared here. And that is, when we educate students, we should give them a purpose for their learning. And now they have a very clear purpose of what this project is about. And the challenge for them is to develop the ability to interlink the various tasks. Now, students find this quite a challenging project, and we've looked at it in many different ways. When we looked at modules delivered on an individual basis, in other words, the earlier PBL exercises, it was fairly obvious that within individual modules in a siloed format, the amount of work that students would be asked to do would exceed what they would be asked to do when the same module was included in an integrated design project. So why do they find it more challenging then if they're in essence been asked to do less work than if the modules were delivered individually. And that is the developing an ability to see how soil mechanics might impact the structural analysis results, for example, or to see what restrictions might be in place because of risks that exist at the site, and how they can develop a transportation plan that will allow for efficient construction. So these are the complexities involved in this project. In non-COVID times, this would require significant planning, but during COVID times, that planning was much more acute and really, really important for the success of the exercise. So there's quite a bit on this matrix. I just want to highlight a number of points. You can see on the left-hand side the 5 modules that are involved in delivering this trigger, or PBL 9. And on the top then are the teaching weeks that take place in a given semester. So we've 12 teaching weeks. And this was a blended experience even during COVID. Students were off campus on weeks 1, 2, and 3, but in week 4 they were on campus. In week 8 they were on campus, and in week 12 they were on campus. You can see within the various boxes there are tasks that students have to do for each module, and we try and coordinate those in a way that while there might be multiple tasks in a given week, and the students are working very, very hard, I have to add that some of these tasks might be relatively lightweight and are just, they can be done in a relatively short time frame. In the soil mechanics side of things, I pretty much have adopted a series of online quizzes. Then there is a submission in week 8 where they submit their interim geotechnical report for how they're going to design foundations for this multi-story building. And then in week 12, they submit their final report with their recommendations. So that's the overall picture. Within a given module, then that has to be carefully coordinated, and students should know upfront how the knowledge that they need will be delivered and when it will be delivered. So I said from a soils standpoint, the building had to sit on the ground that was strong enough. So if you look at the items on the left-hand side, the syllabus is shown under the heading topic, and topics 1 to 4 would be dealing with evaluating the strength of the ground and determining the type of foundation that best suits the structure involved. The remaining items, the remaining 4 items from 5 to 8 are involved in determining how much this structure is going to settle by and whether it is likely that we're going to get any building damage occurring. Part and parcel of running a complex PBL exercise like this is communication, and we issue multiple briefing notes to the students to start them in the process. When we first start, speaking for myself, when I first embarked on implementing PBL without any experience 12, 13 years ago, students soon pointed out the difficulties in my approach, and we often forget that we come to these scenarios having the experience of working in industry and having our qualifications behind us, whereas students are meeting this material for the very first time. So it is really, really important to give them, not give them answers, but give them guidance. And the item on the foreground, in the foreground of the image there, CTL, that is for the center, stands for the Center for Transformative Learning. I think it is important that we do engage with getting feedback from the students through student evaluation of teaching. Sometimes it mightn't make very pleasant reading, but generally speaking, students are pretty good at evaluating our input, and we can certainly learn from it. So scaffolding with appropriate feedback and assessment is really, really important component of bringing challenges like this together. Engagement is a challenge at the best of times, but it's even a bigger challenge when students are not on campus. And I guess there was perhaps a novelty factor with online learning, but those novelty factors can soon wane if we're not doing our job in trying to engage the students in the learning. So some of the ways which I attempted to do this is I tried to bring the classroom experience online. So I generally use PowerPoint to show images, maybe video clips, and basically to save time during our precious 50 minutes. And then I pretty much work on the board. So I tried to bring that into the online lectures where I would sketch and write and deliver my lecture in the normal way. This is an image from one of those lectures. It's done using Microsoft Whiteboard, and these whiteboards can be made available to the students afterwards, and of course the lecture can be recorded also. Some years prior to COVID, and this served me well, I had developed a series of very, very short online lectures on key areas within soil mechanics, sometimes driven by topics that students found challenging. And this allowed me to flip the classroom and get the students to look at the content before they joined the lecture. And we could use our time more productively during the lecture then. I also used in-class quizzes where you would pause your lecture at maybe 1 or 2 occasions and just check in with the students, get them to undertake a fairly straightforward question, try and place it in the context of reality, and see how they're getting on. You can, from the results, and I'm not showing results here, and you can see where the little bar chart is available to record those results, and then you can give them the right answer and work through the details if the students don't get everything first time. When we are face-to-face, then we should do the best we can to have activities that promote learning and promote engagement. We should always remember too that when we're smiling and having fun, we're generally more receptive to learning. And I remembered my days in primary school, not that it necessarily happened that often, but when you got the Fáinne Nua or the little yellow sticker, you felt pretty proud. And I kind of concluded that, well, they might be a little bit older, but they probably still have the same feelings and emotions from getting the Fáinne Nua. So here we are with our Geo Star of the day, been rewarded by his colleagues. Technology is obviously very important, and I have, to be frank, given up fighting the mobile phone. It is part and parcel of the world we live in today, and it's just how do we use these things appropriately. This is one way that I use them. It's not that this slide should mean anything to you. The reason for showing it is that I used Mentimeter, which is an online polling system, and you just give the students the code that you can see on the top of the screen there. They log that into their phone when they go to the Menti site, and they can engage then in asking or answer questions. And again, you get feedback and see how they're getting on. This is another Menti question, and I've put this here very deliberately because another key thing, in addition to giving students purpose for learning, is also to give them some autonomy. And here I was polling the students to get their views on how they would like to be assessed. You can see the #1 score there is for a series of online quizzes on each topic, and they're relatively low stakes, between 5 and 10%. So I went with that, and I'll talk more about what came out of that when I look at student reflections. Here is the technology that I used to varying degrees. Big Blue Button was predominantly what I used for recording the live lectures, for having breakout rooms to facilitate PBL activities. the in-class quizzes and the chat room. MS Teams is a similar tool, if you like. I used Panopto sparingly, and if there was a topic that I wanted to pre-record that I might be able to share year in, year out, then I generally did that with Panopto. I didn't use OneNote that much, but I know my colleagues did. It has a lot of advantages for recording. I'll talk about some of them in a moment. You saw the output from the MS Whiteboard that I used, YouTube and VLE. And pretty much YouTube has got answers to most things we want to know. So it can save us reinventing the wheel, so to speak. And as I put this list together, I just pondered, you know, if COVID had happened 5 years ago, I think we would have been in deep trouble in terms of our ability to engage students and, in fact, even to deliver our courses. So some of the reflections that the students shared, the student numbers have no great significance, but I just thought some of these things were interesting. They start off obviously by highlighting COVID was an issue and how they found things much more difficult. But they say this has led to becoming more capable and for looking to find information myself. So in other words, becoming independent learners. In purple there, you can see this also increased my personal responsibility as I had to become more self-reliant when I didn't understand something in a lecture. I now make more of an effort to look up the literature to solve my problem, rather than going asking the lecturers or others for a solution. And an acknowledgement that the integrated design project made them realize how interlinked and dependent all of their modules are on one another. In engineering, any of you who are in the field probably are aware that laboratories are a significant component of our teaching and learning, and during COVID we couldn't do this. Thankfully, through my teaching contacts, I reached out to my good friend Professor Mark Jacksa, who has put together a series of excellent videos on how experiments in the soil mechanics area are run. So while the students couldn't engage in the tactile nature of the experiments, this was the next best thing. You can see that the students did regret not being able to do the labs as they might have done in previous years. There was a longing for, you know, I guess, human contact and being back in the classroom. Students, you know, if they don't like to ask a question during the lecture, they can come up at the end of the lecture and seek clarifications. And that this is the third component that I think is important in our education, and that's promoting the mastery. So doing something and becoming better at it because it is important. And those three words, autonomy, purpose, and mastery, I borrowed from a guy called Daniel Pink, who has written a book about what motivates us. And I found that very, very insightful and helpful in organizing my material. One or two other reflections just to finish then. And this one, I think, is a real problem for us in the future. It says we had lots of pre-recorded lectures and I didn't feel the need to attend the live ones as I knew they'd be recorded anyway. He goes on to say that I took the easy option and I kicked the can down the road, but quickly learned and that it was very easy to fall behind, and you know, you really have to catch up. So I guess he recalibrated and attended the lectures from that point forward. And you might remember the Menti slide where I gave them some autonomy in terms of how they might be assessed. And the student says, I felt the quizzes every second week helped with this, as I had to follow the lectures and keep up with what was happening. So that's, to my mind, you know, a better approach than what happens traditionally, where we have a largely weighted end of semester exam, where students cram for it and 3 weeks later they've forgotten much of what they've learned for the exam. Again, there might be some debate around that, but that's just my view. So some observations I made then from our online teaching. So when we're examining through online quizzes, in terms of cognitive skills, the easier skills that may appear in some written exam papers that are proctored, they really don't have a whole lot of place when when students have full access to all their resources. So the lower part of Bloom's taxonomy shouldn't really be examined in online questions. Better to move a little bit up the triangle and look at questions that measure students' ability to apply knowledge and analyze different scenarios. And then to get closer to the top, if we ever actually reach there at undergraduate level, but we certainly strive to, the higher level cognitive skills like evaluating things and creatively solving problems, they can be evaluated throughout the course of the semester, where students can develop these skills with time and also with the ability to reflect. And reflection is a large component of our students' work. We ask them to reflect quite a bit. And we evaluate these higher level skills in our interviews that generally take place at the end of the semester. One of the things that I found, I think people generally found this, and there's a whole host of reasons for it, no particular reason to suggest that students are any different year in, year out, and there are some differences, but the results that I got in my particular module were higher than they were previously. I've just misplaced the 2019 results for this slide. I couldn't find them this morning, but you can see the trend, and now that we're moving on into 2021, there is a slight drop in the numbers again. Students do generally find the subject difficult, so I'm happy to talk about some of those things in our discussions. So looking ahead, I think that online lectures are here to stay. I think students are pretty much demanding them, and I think they have benefits. Use of online tools like OneNote and Microsoft Whiteboard are very, very useful for keeping records of, we'll say, agendas for PBL meetings, keeping weekly meeting records. Lecturer can then log into the OneNote account and provide feedback or see how progress is going, and record the progress. Some of the challenges we're facing is that I don't see online as a substitute in any way for human encounter and face-to-face activities. The hidden curriculum associated with going to college, the development of your social skills, the professional ethical skills, and that's all missing from an online experience. I think students learn as much outside of the classroom as they do in the classroom, and maybe more. We had issues with international students working in different time zones. That's a problem if you want to run synchronous lectures, which I do. Also, introverts perhaps tend to become more introverted in online situations. And how do we manage that? And then cameras, do we have them on or off? And finally, just to leave you with some points for discussion, did having a PBL culture in our program leave students better prepared for online learning? I have some comments to make on that. What aspects of online learning enhances a PBL pedagogy? And then for me, a big one is, should online classes be synchronous or asynchronous? So with synchronous during a pandemic, there's a sense of togetherness. If they're pre-recorded, maybe you still have that isolation, feeling of isolation. I certainly run mine synchronously. And then finally, how should we use face-to-face time in post-COVID situations? So I'll leave it at that. We've got about 15 minutes for questions and answers. Hopefully there are a few, and I'm happy to take them. So thanks very much for your attention.
Yeah, thank you, Declan. Very nice overview, very focused study there, or depiction of what you guys have been doing, which is excellent.